All right, welcome everybody to our talk. Everybody can hear me? Awesome, great. This is still new, and so I'm getting used to like talking with a low voice, which is good because I'm starting to go a little hoarse. So I'm Kenneth Berry. I'm a sales engineer at Sumo Logic, but I don't do exactly what a sales engineer would do. I am in charge of managing the environments that are used by the sales engineering org to demonstrate Sumo Logic to potential customers.
I'm Justin Clark. I'm the lead DevOps engineer for Turo, a global car sharing platform.
Awesome. Thanks for the intro. So before we leave today, we will have failed if we haven't accomplished a couple of things. We're going to talk briefly about what Kubernetes is. Some of you may be using it, some of you may not. We want to make sure that we've at least covered the basis enough so that when we talk about what we're going to monitor and why it's crucial to monitor those things, you have some context for it. And finally, we want to talk about what we're doing at Sumo Logic to help you take advantage of the monitoring that you can do inside Kubernetes. And we're going to be showing you some new features that are coming out. So first off, let's talk about why Kubernetes in the first place. I'm going to give a little backup. So Kubernetes is an open source container orchestration platform that was developed by Google in 2014. And it was built by Google based on the experience they had using containers to run their application and environments using an internal tool called Borg. What's really nice about Kubernetes is it'll work on both private and public clouds as well as bare metal architecture. It essentially runs anywhere. And it fills the hole where, as we have moved away from having, as our friend Ben Newton would say, we've moved away from having servers that have names because they're pets into servers that are like cattle that we can kill at any time and not feel bad about. The need for being able to orchestrate around and manage these more segmented, I guess maybe a way to put it, environments has increased. And so the ability to, and we're doing that with containers. We're segmenting, or we're dividing and conquering, but we still have an increased need to get to orchestrate it, and so Kubernetes fills that need. Kubernetes is since its release in 2014 to the open source community, Kubernetes has seen unprecedented growth and adoption across multiple industries. And it's currently managed by, there are only two, so there's a foundation called the Cloud Native Compute, CNCF Foundation. And they're an organization, a Linux organization that's dedicated to making cloud native computing both universal and sustainable. And it's backed by top enterprises who are dedicated to the same goal. There are other projects, and before I go to my next slide, and there are other projects that are hosted by Kubernetes, by the CNCF, that integrate well with Kubernetes. There's a handful of products that you can see, or projects that you can see here. One of them I actually just spoke about, Prometheus, which is the other graduated product. So I appreciate, with 1,800 contributors to the Kubernetes project and 41,000 stars, we continue to see growth in the Kubernetes project, and these members of the CNCF help to contribute back to the Kubernetes project. So this is an overview of the Kubernetes architecture. At its heart, Kubernetes consists of a control plane which runs on the master node, and it's in charge of the orchestration and ensuring that the desired state of your containers and your cluster is met. The nodes are the collective compute and the place where your applications are run. So in the concept, I'm setting something up for you, in the concept of if you're using an EC2, or in AWS, these would be your EC2 instances where your pods are going to run. And pods, as I mentioned them, are the smallest unit of compute that you can actually configure, and they consist of one or many co-located and co-scheduled containers. All right. So, this is to you.
Thank you, Kenneth. So, what I'd like to talk about today are some of the metrics that are important for us at Turo that we like to monitor inside of Kubernetes. So we're going to break down the architecture a little bit more. We're going to go over some of the parts that are inside of the control plane. We're going to go over some of the parts that are actually running on the individual nodes. And of course, last but not least, the pods and what can we monitor there. So the very first thing is your API server. This is your front door to getting inside of Kubernetes. Anytime you want to make a change inside of Kubernetes, whether it's through kubectl, whether it's through a Helm chart, or maybe you're making Spinnaker changes, everything is going to be communicating through the API server. This is what's going to be using all of your resources to commit your changes inside the cluster. Now, things I want to monitor, I want to make sure that the API server latency isn't starting to creep up. It's very possible, for example, a situation we ran into where we were using Spinnaker with a V1 provider and a V2 provider. The two collided and caused an extreme amount of CPU load on our kube-API server, which made it very unresponsive. So without having monitoring around that, it would have been very difficult for us to diagnose, as kubectl and all the rest of my tools couldn't connect and talk to the API server. So luckily, having better monitoring around your API server gives me the ability to understand what it's doing and what kind of load that it's presently under. The next thing up is etc.d. Now etc.d is a value store, and Kubernetes uses this for storing all of your desired state. Remember, Kubernetes is a declarative system, so I declare the state that I want it to be in, and Kubernetes will continually iterate over that, doing its best to correlate all my changes so that it's moving toward the running state. Anytime we are using etc.d, you need to remember that it's using the RAF protocol, which means that it requires to have a quorum. If we have leader changes, or if quorum is lost, etc.d falls into a read-only state. In a read-only state, you can't make any changes to the API, you can't get new state coming back from your cluster. So it's imperative that you monitor this quorum to make sure that you never lose that state. And at the same time, disk space is really important. If you ever lose your backup for your etc.d, you may lose all the state for the entire cluster. So you want to make sure that you always have good backups of your etc.d.
Justin, have you ever lost quorum before?
I have. So we hit that perfect storm where we were going to be upgrading one of our masters running etc.d, and right as we started upgrading that machine, we had another instance crash. We only had 3 in that quorum, and so with 2 of the nodes down, we lost quorum. So in that instance, I had to manually go inside of the pods and actually add members to the quorum to bring it back up from backups. It is a very manual intensive labor, so hopefully maintain your backups and make sure that you don't actually take down more than 1 at a time. The controller manager. Now the controller manager since 1.6 has been broken up with both the kube controller manager and the cloud controller manager. The controller manager is responsible for continually running over your desired state and coalescing it with your running state. Anytime that I make a change using the API server, the controller manager is going to monitor that and see if it's going to be matching in the desired state. So, do I have enough nodes running? Do I have all my pods? I want to make sure that you're constantly iterating over this and making sure that it's coming to my desired state. Things to monitor on this, similar to the API server, I want to make sure we're monitoring end-to-end latency, but additionally with your cloud provider, you want to make sure that you're getting end-to-end latency with your cloud. In addition to that, you're not having failed requests going to your cloud provider. If you have any failed requests to your cloud provider, we're going to fail to manage the actual individual nodes that are coming up inside of your cluster. Now, the scheduler is responsible for actually scheduling the individual pods on your nodes. It's going to ask the simple question of, where can I schedule this? Now, I make it sound like that's a simple question, but keep in mind that it's doing a lot under the hood. It's comparing available resources versus resource requests. It's comparing availability of individual nodes versus new nodes that are becoming online due to scaling. And all of this is brought into a general logic that's going to decide where to schedule. Now, things I like to monitor is failed requests to schedule. And those failed requests to schedule might be, well, we ran out of quota. And that quota could be either that we're having a back off loop because we're having pods that are coming up and are exceeding immediately their pod limit, or maybe you're hitting a namespace limit. If you have quotas on your namespaces and you're trying to launch too many pods, say for example you're doing like a blue-green deployment and you forgot to actually double the namespace quota to add the blue-green, well, we're going to hit a limit there as well. And of course, last but not least, don't forget about anti-affinity. If you have your pods that are supposed to be affinity towards certain nodes, but we don't have nodes that have capacity to take that on, the pods are going to fail to schedule.
You know, it's funny that I actually ran into an issue a couple of months ago with the environment that I manage for our demos, where I had both a resource limit and a pod limit. I did 110 number of pods per node. I ran into both of them at the same time. Unfortunately, I wasn't drinking my own champagne at the time, and we'll get to how I'm solving this later.
And the last thing before I change this slide too, I also like to monitor our bin packing. So bin packing is how many objects I can fit in a finite amount of space, right? So this is how many pods can I schedule on individual nodes. Now, the default Kubernetes scheduler leaves a little bit to be desired for bin packing. It's very possible if you set up an auto-scaling cluster that instead of shutting down a pod and scheduling it over somewhere else, it simply will scale up a whole nother node to schedule a pod. And that's because by default, out of the box, Kubernetes doesn't ship with a descheduler. It won't reschedule pods that are healthy and running. So consider adding the descheduler. It's currently in incubation, but it's something that we like to add, and we monitor our bin packing to make sure we're getting a good value to our money that we're spending on our EC2 instances.
So is that why the machines, whenever I've changed configurations, don't go away?
Potentially, yes.
Okay.
Right? Because if you still have pods that are running on them, they won't scale back if you still have healthy things on there. But if you have the descheduler, it's possible for it to drain some of those pods off and for that node to be shut down then. Next up is kubelet. Kubelet is actually a daemon that runs on all of your nodes. Now, just to go back, we want to make sure that we have containers that are running. Remember that containers are scheduled inside of pods, okay? The pod itself can have n number of containers, right? You might have a primary container, you might have a couple sidecars that support it. The kubelet is going to monitor the container's health, and it's going to interact with your container scheduler. Now, most of us are probably running Docker under the hood, but you might be also running Rocket or any other open source container manager that is supported by Kubernetes. Additionally, it'll bubble up stats on your pods using cAdvisor. And remember, it's pulling this from the individual containers that are running on that node. So in this case, we put up an image of the monitor lizard, because essentially we're monitoring a monitoring service in order to get this information.
Right, because if your monitor goes down, how do you know that it's down?
You'll never know. Nodes and pods. Now, I probably should have broken this up into 2 slides, but let's go over first, what is a node again? Remember, a node is a basic level of compute inside of Kubernetes. This is equivalent to like an EC2 instance inside of AWS, or a Google Compute instance, you know, whether it's a virtual machine or if, say, you're using bare metal, this is your bare bones server. So at the bare bones there, you want to monitor it just like any other server you would. So we want to make sure we pull out stats on your CPU usage, your memory consumption, your general file system load. These are things that any server that we want to monitor to make sure it's staying healthy. If a node is going unhealthy, it's going to cause all those pods potentially to get rescheduled somewhere else. So as much as possible to reduce thrashing and rescheduling of all of our pods, we like to monitor the individual nodes as well. Now the pods themselves, we touched on this a moment ago. Remember the pods, basic level of...
Pods are like little slices of a node.
Right? Dividing it up, it may contain multiple containers. So again, since I kind of went over that a little bit on my previous slide, I won't go into too much detail, but the pods itself, we control a lot of statistics from it using cAdvisor. So we want to make sure that we continually monitor all the scheduler health for individual pods, and to make sure that we don't have pods that are stuck in a restart loop. We've run into restart loops at Turo before, where we have JVM coming up. The JVM might have a heap size that's too large for the pod, or maybe we set it for too small of a heap size and it's exceeding that and the JVM is crashing. So make sure you can tell the difference whether it's Kubernetes is restarting your pod or was it the JVM restarting itself. Kenneth, I'm going to hand that back to you.
All right, thank you very much. So now we're going to get into what we're doing at Sumo Logic to work with this data. So I literally just in that corner finished giving a talk on how we handle logs using a tool called FluentD, and I highly recommend you go and get the recording and review that. But we're using FluentD in Kubernetes to get the log information. This will cover things like orchestration as well as the logs that are being generated by the apps that are running on your pods. FluentD is an open source collector, and what's nice about it is that you can run it inside your Kubernetes environment. So wherever you're running Kubernetes, you can run FluentD as a standard, so it'll essentially run anywhere. On the metric side of the house, currently we utilize a Kubernetes add-on called Heapster. Heapster provides you with metrics at sort of a high level about the different various components in your cluster. You can monitor some of the key components. There is a downside though, which is Heapster is being deprecated in the next couple of versions. I think actually may be deprecated now, but the end of life is in the next version or two of Kubernetes. And so in the next couple of weeks, unfortunately we couldn't finish it to show it to you here, or to release it today, but in the next few weeks you'll see a new collection strategy that we're developing that will utilize the metrics that are being provided by Kubernetes. I mentioned CNCF earlier. Many of the projects in CNCF integrate with a tool called Prometheus. Prometheus is an open source monitoring tool, and it's a little bit different than some of the other tools in that it provides a pull-based. It has a pull-based strategy for getting metrics, and the way that it works is these Kubernetes formatted metrics. Let me be clear. Kubernetes is a tool. Prometheus is a tool, and Prometheus is also a format for metric data. So I just needed to clear that up. So as these metrics become available, we're building a tool that will grab these metrics that are native to the Kubernetes environment. Kubernetes, as well as many of the other projects supported by CNCF, integrate with Prometheus, the tool, and provide their metrics in the Prometheus format. Okay? So the way that it works is Kubernetes is fully integrated with Prometheus, and it provides endpoints that provide these metrics. I mentioned earlier that it's a pull-based strategy. So these endpoints, which are usually in the slash metrics, for those familiar with Kubernetes, that'll make a little bit more sense to you than whenever I first learned about it. These metrics are available, and Prometheus can access these endpoints and gather the metrics on whatever interval you've specified it. For nodes, Prometheus can utilize something called a node exporter, which provides host level metrics like the CPU and the memory utilization, which can be useful for monitoring the health of your nodes. And then there's one other tool that Prometheus can take advantage of called kube state metrics. It's a Kubernetes add-on that provides you with, the only way I can describe it, it's almost like, because Prometheus is all metrics, they wanted a way of being able to, using metrics, describe like health conditions. Are my pods healthy or not? Usually I traditionally thought of that as logs. But with kube state, we can actually get those in the form of Prometheus metrics. There might be there's a metric that is this pod healthy or not? Yes or no, and it's a 0 or a 1. And so we can actually get these metrics out of kube state. And all of these metrics we can gather, can be gathered by Kubernetes. So we've built an open source tool that'll be released soon, like this quarter, that will provide a way to be deployed. It'll be a small package that you can either deploy using kubectl, or which is the standard Kubernetes CLI, or a more robust tool like Helm, which is a application and configuration management tool for Kubernetes. And it's highly configurable. We almost have it done. I wish I could show it to you today. We almost have it done. It's highly configurable so that you can, as I mentioned in my other talk, you'll be able to adjust what kind of metrics come out. I cannot express how much data is available in this Prometheus format. When you get back to your boxes, to your Kubernetes environments, I recommend by default these slash metrics are turned on for the control plane components, and so you should be able to hit those and see them. But it is crazy verbose. And the tooling that we've put together selects the bits and pieces that we feel are most vital to be usable to monitor the environment. Of course, you'll be able to adjust it if there's other things that you want to pull in, but we've pulled in what we believe are the minimum for you to effectively monitor your system. And we're going to be releasing along with this a new Kubernetes app, which is working directly with the metrics that are going to be available coming out of this new Prometheus scraper. I wanted to call it Frank, because my buddy Frank is the one who wrote it. We're going to call it the Frank scraper, but they shot that down. So the new Prometheus scraper, whatever its final name is, will pull in metrics to feed these various dashboards. So, for instance, on this monitoring, control panel plane health, we have some general indicators for the health of our system overall, as well as a key indicator, which is a kube system pod restarts. Help me out. If you saw, why would you want to see, or what would stir your curiosity as a number in the kube system pods restart?
So immediately the thing that catches my eye on this chart here is the kube system pod restarts. Notice the kube scheduler currently is in red. I would start taking a look at that to figure out if the kube scheduler is in an unhealthy state, that it's failing to keep coming back up.
Awesome. One of the things that I want to emphasize here, and I'm going to go through the other parts of the application, is it isn't released yet, and we would appreciate any feedback that you have. Y'all use Kubernetes more than we do, and we're very open to getting feedback as we continue to develop this. And even after we get it released, we'd love to have, hey, do you think you could add this? I think that, I mean, you can always add your own, right? You know how apps work, you can add your own, but when it comes to furthering the solution for the next person who comes along, we'd love to get whatever feedback you might give us for the kinds of things that we might show. For the state of the Kubernetes cluster, we have some panels that help us to, what is the OOM?
OOM is out of memory kills, right?
That's right.
Anytime you have a pod that's exceeding its limit, you're going to have out of memory kills, and it's very, very difficult sometimes to monitor that. So it's awesome that it's built in here.
Is that what happens whenever you, like, I don't know, maybe 170% provision your boxes?
You got it, right?
That would explain.
If you start exceeding the pod limit, you're going to start having out of memory kills.
That would explain some outages I had. And this last section that we have is for the utilization. So this is more pointed at some of those host level metrics that we were talking about. Okay, so we've got some time for questions.
Okay. So if you have a question, just raise your hand and I'll bring the mic to you.
Are we going to hear?
Through these speakers.
Do you have? Do you guys have any plans to avoid using Prometheus node exporter, so that I can have a Sumo Logic physical agent installed in the instances where my Kubernetes is running, and that would automatically pull data from my Kubernetes system and post it to Sumo Logic UI?
So you'll still be able to do that if you wanted to. It might break the convention. Let me just ask a question. When you say I want to install a Sumo Logic instance in your,
so the way we have our system set up is we use a Sumo Logic physical agent running in our system in the form of containers that pulls out metrics from my system. So what if, like, I don't want to be using Prometheus as like an intermediate step? Rather, I just want, yeah.
So remember I talked about Prometheus is both a tool and it's also a format. So all the Prometheus log metrics, they've been there for versions and versions and versions. They're already there. Heapster is, when you're running in our current solution, which is what you're doing now, the metrics come from Heapster, and that's going away, and we can't control that. So if you want to, you'd have to like freeze the version of Kubernetes you were using to something that still had Heapster to continue to do that in the future. But you won't, to be clear, Kubernetes or Prometheus the tool, Prometheus the format, you do not have to run Prometheus. You'll run a separate thing that will be very similar to what you're doing now, where you're running a pod that's running Sumo Logic on it. You'll switch that out for this new exporter mechanism that we're talking about. And it will collect them the same. It'll collect in the same method. Like you'll get metrics, you'll get logs, but it'll be gathering them from the Prometheus format endpoints that I was talking about earlier because the heapster component's going away.
Okay, thank you.
You're welcome.
This is a question for the gentleman from Tura.
Yes.
Are you guys hiring by any chance?
Yes, we are. Thank you. Good question.
Wow. No shame. I recognize that guy.
It's not a plan. I don't know what you're talking about.
Do you have any experience with Rancher or other tools for managing Kubernetes? And is Sumo going to be supporting monitoring for Rancher or any other tools?
Great question. So you can't see, but my notes are missing up here, and I forgot a point I wanted to mention earlier. So the solution that we built runs in Kubernetes. Anywhere, that means literally anywhere that you run Kubernetes, you can run this. Rancher does Kubernetes, you'll be able to run it there. Absolutely.
EKS?
Yes.
Exactly. Yeah, any hosted or manually managed, any one of them, because it's all Kubernetes under the hood, all of them will be able to produce the same metrics.
That's right.
This tool that's being developed, do you guys have any public information regarding the plan for rolling that out?
Yes. So you will. So the tool will be coming out in the next few weeks. Like it's. So you see. Oh, maybe I can't go backwards. This right here. Oh, I failed to mention one more thing. Sorry. So you'll notice that these are metrics panels, and we couldn't. One of the reasons we couldn't release it today is because single value metrics panels hasn't come out yet. Like we're using it internally because it's on our development environment, and so it's like done-ish. We just haven't GA'd it, and that is one small piece of why we haven't come out. And also there was some finessing we wanted to do in how it was deployed. But absolutely talk to me afterwards. We are looking for people to try it out and work with us. So we can work with you, yeah. Oh boy, a question from last time.
No, actually that answered my question.
Okay, good.
But to follow up, this tool, does it only collect from, well, rephrase, is this tool able to collect any Prometheus format metrics?
That's all it collects is Prometheus.
So if I point it at something that's not Prometheus itself, it'll just take it anyway?
Yes.
Okay.
Yeah. Wait, I'm sorry, let me clear. If you pointed at something that's not Prometheus format, it expects the Prometheus format
right.
at the end.
No. If it's metrics that are in Prometheus format, but not necessarily something that you would include by default.
Sure, yeah.
Yeah.
Anyone else? Okay.
Right over here.
Oh, one more there.
Yeah, I just say sorry for talking at the start. I didn't realize that it started when I was talking over here. But you were talking about stuff being verbose. I've had like 2 or 3 teams that have sent vast quantities of logs to Sumo Logic through FluentD from kind of experimental Kubernetes clusters. So it already seems to be quite a problem for us, the volume. Do you have any suggestions or guidelines about what sort of logs you would want to filter out of a Kubernetes cluster?
If it's an experimental cluster, I'd want to filter out everything.
I kind of agree with you on that one. Luckily, one of them sat right next to me, so I went over and gave the guy a hard time, and he stopped doing it. But
that's probably a better question for you. If you were experimenting with a Kubernetes cluster, what's the minimum? What's the minimum viable data you'd want when working with the cluster? I think that's what no data's a solution.
I guess I was thinking from a logging perspective, what's important, say in a production cluster, because we probably would not be able to ingest all of it.
Sure. I can speak from experience if you like.
And I have something else after.
Yeah, so if it was just a test cluster, especially if you're using development applications, I'd be more interested in the actual applications logs than I would be about the raw cluster. I'd be monitoring like individual pod health to make sure that I'm capturing any restarts or any unhealthy limits, or that I'm starting to exceed on that. But overall, in terms of the cluster itself, if it's just kind of like a testing, staging like cluster, we don't need that fine grain, all the metrics we need out of the cluster. Just basic container health and pod health is probably enough for your debugging.
Yeah, and that's really useful because as we're moving into containers, one of the things that you need to do is not only do you need to make sure that the pod uses images that have the assets that you need to run your application, but you also are trying to right-size your container. And I've actually had issues. I bought into the dream of containers removes the ability for someone to say it works on my box. Well, I actually had a scenario where I was tweaking some of the Docker commands, and I was actually slightly adjusting the size of the containers. And whenever I actually got that into production, those switches weren't there. So that's another reason why you want to monitor that's one of the reasons why you want to monitor the metrics around the health, but you probably wouldn't need the same verbosity, to be sure. And on top of that, when I was mentioning verbosity, what I mean is the Prometheus metrics that are available, it's like there's an ungodly number of metrics. Like everything. I can't even, like it's literally pages and pages and pages and pages. And we're just going, we need this one, we need this one, we need this one. But I highly recommend that for anybody who's going to be working with the new metrics coming out of in the Prometheus format through these endpoints, the /metrics, go and take a look, because you may see one and go, I actually want that one. And the tooling that we'll have will allow you to say, okay, cherry pick that one also if you want. But I would go with him as well. You just really care about the basics, helping you make sure that the container is going to be right-sized in your environment.
I'm going to add just one more, just because your use case of making small tweaks to a container. If you guys haven't ran into this before, especially when deploying Kubernetes, make sure you never use latest for your Kubernetes images. Always use unique tags so that you can be more assured that you're using the actual version you expected, where if you're using latest, anyone can overwrite latest. That could always be a different version. So try to use unique tags and never rewrite the same tag.
Not to digress, but I make the same recommendation when it comes to, as a former DevOps engineer, when it comes to using our installed collectors, because heaven forbid we introduce a bug into our
latest
collector, and then you pull it down because you want to, live on the bleeding edge and you bleed. So. But also use our latest collector. I'm supposed to say that.
Any other questions?
Right over here. I'm going to get in so much trouble.
It's not directly related to Kubernetes, but you mentioned recordings of these sessions.
Yeah.
How do we get those?
Oh, man. Now I wish someone could hear what I was saying.
We all wanted to ask that.
Yeah, right. So I will tell you what I've told verbatim. There will be recordings. I think we're doing, I'm trying to quote exactly, we're doing slide capture and audio. So that's what I mean when I say recordings. They will be available, but I can't tell you if that means that they're available like as soon as we step off, or if they're going to be available in a day or two, or if they're going to be available in a week. But I am told that they will be available. But chat with me afterwards and I can track someone down.
I'll chat with you after.
Last year was 2 weeks. Okay. Let's all cross our fingers that it's sooner than that this time.
Any other questions? Okay. Thank you so much, Kenneth. Thank you so much, Justin.
Thank you, guys. Thank you so much for coming.
Thank you for coming. I'd like to call upon Richard from Product Marketing to give Justin a small token of appreciation coming out here.
It's a small token for being a presenter here and sharing what's going on with your company. So thank you for presenting.
Thank you.
Thank you, Justin.